Nigga, lay it down.
Change the design of sun-observing spacecraft.
Let's learn more about how this team of NASA scientists is chasing the sun.
The corona can be studied from ground-based telescopes only during eclipse. When our eclipse happens, we make use of it and try to test some of our ideas.
Yes.
We have only 2 minutes to do the experiment, and we have been preparing for maybe more than a year.
Nothing can go wrong. Your camera can't shut down, you can't press the wrong button, and because there's no time to change your mind or make alternate decision.
We are going to set up the telescope and observe the total solar eclipse at 4 different wavelengths. And the images taken in these 4 different wavelengths will be used to determine the temperature and flow speed of the corona.
We are planning to take these images using a polarization camera, which will be a first for us. I think it's the first for the solar physics community. So once the moon completely covers the sun, the experiment begins. It's my job to make sure that the image is in the field of view. So at the correct time, one person has to give the command to turn the filter wheel, and for each filter there's a different exposure time. So another person has to enter the exposure time.
Running 3850 right now.
It's a combined effort of 6 different hands. No one person can make any errors.
8121. We do feel the pressure and also the excitement of the eclipse. Still, we have to focus on our experiment. Hey, all done.
It gives a tense feeling, but I believe we'll succeed.
All right, we got another beautiful shot here of Oregon, and we're getting ready to start showing you imagery from around the country.
That's an amazing shot. And right now we're going to toss it to NASA Edge, who is standing by in Carbondale, Illinois.
Tell us a little bit about that, because if you receive social media questions about it, you have the data point to respond to that.
Yeah, you know, honestly, when I first saw the eclipse, before the eclipse, I was like, well, I've seen lunar eclipses, I've seen partial eclipses, probably similar in experience.
Looks like Troy's been a real eclipse traveler. I didn't know this about you.
I'm an eclipse chaser now. It's like, but it was the first one I saw was in Turkey, in Side, Turkey, and the next one was in Micronesia. And when the eclipse happened, it was about 85% coverage and my glasses. At about that moment, I noticed the sky around me started getting noticeably dark, and the temperature dropped about 10 degrees.
We could use it.
Oh my, yeah, we're totally going to love that. And at that, right as the disk of the moon covered the sun, it was phenomenal. You're overwhelmed with an amazing feeling of being connected to the universe around you, because your vision is you're seeing things differently, the shadows are changing, the animals are acting differently.
Yeah, we know about that. I do want to take a quick moment to say that welcome our friends from NASA TV who are joining us from Charleston. Hope they have clear skies there. We clearly are having clear weather here.
We're having clear weather.
A little bit of clouds, but easy to manage. Great to have you guys joining us. Now, like I said, you have time to check this out, to see these sort of eclipse views. What other strategies could you share with our fans to prepare for the eclipse?
Just to basically, when the eclipse happens, spend all of your time with all the different devices and pinhole projectors before and after totality. The biggest thing that I would recommend is when totality happens, unless you have a camera set up on automatic, don't miss a second of the event. Make sure you are looking at the eclipse. Now, one of the things, some people forget to take their eclipse glasses off during totality, and they miss the whole thing there because they think it's unsafe. But you're not actually looking at the sun during totality. You're looking at the backside of the moon, which is pretty dark.
Yeah.
I mean, it's the darkest blackness you've ever seen. And at that moment, you will see the corona of the sun just magically appear across the sky, and you'll see several stars today. I think we have and planets. So we have the potential to see 4 or 5, I believe, planets and stars.
Okay, but you have to be pretty strategic at that point, right?
Yeah.
Because that's during totality.
That's during
right? So you got to
totality.
get your solar experience, and you got to swing your telescope around, see, or will you be seeing them with the naked eye?
You can see it with the naked eye during totality. I recommend everybody look at it with the naked eye during totality.
Perfect.
But as soon as one bit of sunlight starts to come around the sun, trust me, it is super bright, and immediately put on those glasses and start using your pinhole projectors again.
That's a great point, and it's awesome because we're getting lots and lots of good science and good observational data to prepare everyone for how they can experience the events.
And you know something I have to tell you, we have a Flickr gallery that people are uploading many pictures to right now. So we would recommend and highly recommend that you go to the eclipse2017.nasa.gov site. You'll see the Flickr links there, and these beautiful images that you're seeing right now are images that were already uploaded just over the last several days.
Well, what's interesting is it's not just photos from previous eclipses. We're seeing lots of artwork, lots of really creative work. I think that's spectacular and a great part of what's going on during this eclipse.
People of all ages are ready for this.
It's fantastic. Well, I'll tell you what, Troy, thanks so much for coming on. When we come back later, you're going to share with us the results, right? And we're going to talk.
Yes, we checked everything is set up today for 720p. The question we asked about the 1080i had to do with the Unity suit cancer video thing that we did yesterday. And I think it was in 1080i. Can you verify whether or not that's any good, or whether or not we need to repeat that? Checking.
Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Kevin.
She's pausing.
Hi, welcome aboard. We're on NASA Armstrong's G3 aircraft right above the Pacific coast. I'm Kevin Rohr, and I'll be your host on the aircraft. And a big howdy, and thanks to everybody on the ground that's making this shot happen. We've got a fantastic look out the window right now. We're circling above Lincoln City. We got a little bit of cloud cover down there, but we're going to have a fantastic view of the eclipse, and this should prove to be a wonderful day. With me today is Robert Lightfoot, Administrator of NASA, as well as Dr. Zabukin, Head of Science. And what we're going to do is cut to them really quickly so we can have a little discussion. And what are your impressions today, Robert?
Thanks, Kevin. What a great morning so far over the Pacific Ocean. We got to see the first bites out of the sun from the moon. Just an incredible view so far. I really want to thank all the teams that are out there all over the country helping us to get the most science we can get from here. Really going to be an inspirational day and hopefully inspire the next generation of scientists, engineers like me even in the current generation. Pretty inspirational from that standpoint. Volunteers everywhere, so we're excited about what's going on. And I got to turn it over to my buddy Thomas here. This is his field of study. So Thomas, what do you think so far?
Oh, it's amazing. We're already seeing it happening, right? Why do you think this is important to NASA and the United States?
Well, for us, it's a great opportunity. With the totality across the continent, we're going to learn as much as we can. We study heliophysics and astrophysics in NASA, and this is a great opportunity for us to learn even more and have every instrument we have out there available to us to try to understand what we're going to see for the first time in 99 years. So just very, very exciting to see what we can do here and the observations that we're going to get. Can't wait to see the science come in and all the different science we're going to get from here. So, everybody's going to learn something. So you tell me what you think you're going to learn, Thomas, having been studying this for your whole career.
Well, look, my field of study is the sun, and what's really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars we learn here first, but it's also a source of weather and radiation. And actually on board this aircraft we have 2 instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, I think it's important. The more we know about the sun, the more we know space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event?
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by Applied Physics Lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here. On the G3, can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now at partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has 2 predominant lines. One is really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are, about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes affects the Earth and its turbulence. And I'm really going to see what we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
Wow.
And that's great.
Amazing, yeah.
Thank you to those of you on the G3 to fill us in on what you're going to be seeing from there. Here we are on the other side of the country, here at Charleston, South Carolina. I want to give a shout out to the college. The students here have been so incredibly great for us, and we are actually going to have a chance to go back to Salem, Oregon, and find out a little bit more about what they are seeing there. They're talking about this moon picture right here.
Right, we've got a live picture right now from Salem, Oregon. We were showing you earlier in the broadcast, and as you can see, as we've been sort of describing it as the moon taking a bite out of the sun, it's continuing to happen, and what it looks like, Karen, is like it's almost like the sun. What we see is almost like a crescent moon, but it's not. It's the moon is actually the black portion in the upper right-hand portion of the sun that's being blocked out as we get closer and closer toward totality, which, as Robert and Thomas said from the G3 aircraft, is only about 30 minutes away for folks in Oregon.
And we will go right to Madras, which is right near Oregon. This is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks are talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as they mentioned earlier from the G3, about 30 minutes from now to totality there, about 90 minutes to get to where we are here in Charleston. So that means what? If time's right, about 2 hours, we'll be at totality here.
And we are now going to go to Salem, Oregon, where Jesse Carpenter will be talking to Nikki Weil, a solar scientist from NASA.
Welcome back to Salem, Oregon. It is clear, but yes, it is a little bit breezy here
windy,
today.
yeah.
Isn't it? Yeah. I'm joined again with NASA solar physicist Nicolene Weil.
Hi.
Hey, so why don't we just take a look at what we've got going on here now that transit is deep underway.
Yeah, so the moon is crossing in front of the sun, and it's kind of looking like the moon is taking a bite out of the sun. And if you guys have any colanders with you, like a kitchen colander strainer, you can actually see, if you let the sunlight come through that colander and look at the shadow on the ground below you, you'll actually be able to see the projected image of the moon taking a bite out of the sun down on the ground in front of you.
Yeah, that's cool.
Yeah.
So you can just get something from the trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So there's sort of three outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the less bright than the sun. It takes something special, like today's total solar eclipse, to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool. So I think what we're going to be doing now is sending it back to NASA's Eclipse Central in Charleston. Take it away, guys.
Thanks.
And welcome back to Charleston. You can hear these students are really excited for us. And I gotta tell you, I had the chance to interview some of them just a few days ago. The College of Charleston students are excited, and I wanted to find out what they knew about the eclipse. Let's watch the video.
All right. So right now what we're looking at on your screen is...
Hello, I am Karen Fox with NASA TV. I'm here at the College of Charleston in Charleston, South Carolina, and we are going to spend some time interviewing students to find out what they know about the total eclipse of 2017. What's happening on Monday?
The solar eclipse is happening.
Monday, the eclipse.
That's the right answer, the eclipse. Are you ready for the eclipse?
Oh, I'm pumped. I've been talking about it all summer.
What is an eclipse?
When the moon moves in front of the sun.
It's when the moon passes in front of the sun and creates a shadow on Earth.
What is the closest star to Earth?
The sun? The sun?
The sun.
The sun? Yes, the sun! Very nice. Will you demonstrate for me putting these on?
We're going to put them over the glasses.
The music you associate with the eclipse. What have you been listening to? What are you going to listen to?
Here comes the sun.
Total eclipse of my heart.
Do-do-do-do.
Da-na-na, like...
Getting a lot of questions on social media, people just emailing us asking about that. You must have the glasses unless you are in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Weil, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on our tree. There's some really wonderful ways of catching imagery of it. So, be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little bit about the science that
We should, but before that, I just want to give a shout out to our website because you're talking about all these great ways to indirectly view it. And again, just a plug for the eclipse2017.nasa.gov site where you can find all kinds of information, but especially some do-it-yourself instructions on how to create some of those indirect viewing methods.
Great, we've talked a lot here about the partial eclipse. Nikki Weil, who you just heard talking, she studies the corona, that is the atmosphere around the sun. And she was telling me just the other day how excited she is that she is going to be able to see that with her naked eye during the actual total solar eclipse. So that's what's interesting. We can only see that normally from space with our space telescopes.
Right, and even with that, I was talking to one of the heliophysicists back at NASA headquarters in Washington, D.C. Recently about this, that even with those artificial eclipses that they create from the coronagraphs, they're called, in space, it doesn't give you the same viewing opportunities that we have with a natural eclipse like we're seeing now. That there's actually a couple different layers of the sun's corona. We have the outer corona and the inner corona, and because of the way those coronagraphs work, they do not allow a good image of the inner corona, the part that's really close to the sun's surface. Only the outer corona. It's only during an actual natural total solar eclipse like we're viewing today across the country that scientists, heliophysicists, and others, and just the general public are able to see the entire corona, and that really gives them a lot more information. And remember, for these scientists, no matter where they are, they only have that brief, maybe 2 minutes, maybe 3 if you're really lucky, right in the center line of totality, to see the entire corona and get those measurements.
Yeah.
again, Karen, as folks are looking at their screen right now, you see that double image, Salem, Oregon there on the left, and nearby Madras on the right. Two different images with two different types of telescope using to view this eclipse. It's still in the partial stages, starting to get closer and closer toward totality in just a few minutes.
And stick with us because we are going to be tracing this eclipse all the way across the country. Not only does everybody in the country have a great view, but we have some views from the sky, don't we, Sean?
That's right. Looking up from the ground is how most of us will experience today's eclipse, but researchers at Southern Illinois University wanted a different perspective. They wanted to look down at Earth to image the moon's shadow. In Illinois and across the United States, teams are using high-altitude balloons for a unique perspective.
Right now, they're getting ready to launch a research balloon from Saluki Stadium in Carbondale, Illinois. We're going to go back to Carbondale, Illinois. The primary payload will be a real-time, high-definition video system. So let's check in on the progress of that launch.
Let's take astronomy here. We're experiencing it on lots and lots
Eclipse
of
in 4D. It's just like being on the surface.
But, you know, to actually understand the corona is very important because all sun-like stars have their corona. We need to understand why the energy is released in the way it is.
All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
That is what's going to let that get safely down to the ground.
And all those instruments
and all the instruments attached as well. That's a beautiful sight.
Okay, can you hear me okay? Right.
Yes. Launch in less than a minute. So
this is Kevin Boucher. Sorry about the little mix-up. I was too enthralled. I was too enthralled looking at this fantastic weather balloon that has just launched. You can probably see it behind me. It is pandemonium here, but it's good pandemonium. One of the weather balloons has launched, and with me is one of the team members. Introduce yourself to the entire world. No pressure.
Hi, my name is Colleen Fava. I'm the
Nigga, lay it down.